Okay, we're going to start talking about tropical weather this week. So let's take a look at what's going on there. What conditions, what is tropical weather really is what we're going to talk about. It's weather that basically occurs where the sun is directly overhead at some point during the year. So there's little seasonal variations. You don't get fronts down in that area, and the air masses are generally very humid and very warm. So sometimes thunderstorms develop, particularly along the intertropical convergence zone, uh, and just follows north and south with the sun. And guess what? Summer is the rainy season, winter is the dry season. Very little pressure gradient. That's why we use what we call streamlines to look at it. Think about a streamline. All you're is you're just following the flow of the wind. So if you started on a wind barb and just followed around to the next wind barb and so on, that would be how the wind would flow. One of the biggest issues in the tropics, of course, is hurricanes. They're at least 74 miles per hour, and they are definitely different than an extratropical cyclone. You notice the hurricane has an eye, and it also has what we call an eye wall. So in the eye, the winds are air is actually subsiding or going down, drying it. Very warm temperatures in the eye of a hurricane. And around it, there's these massive thunderstorms that are just a ring of cumulonimbus clouds with very, very heavy rain and very strong winds. So here you can actually see that. The winds spiral in towards a hurricane, getting closer and closer, picking up speed as they go inward and upward at the same time. That's why you find what they call spiral bands, which are bands of thunderstorms, really, or showers that are well out ahead of a hurricane. And you'll have an intense band maybe go through your house, a little bit of wind, a little bit of rain, and then the next one will be a little more intense as you get closer and closer to the storm until you finally get in the eye wall. And yes, hurricane winds can go out well out, as you're going to discover with Sandy, or they can be fairly tiny, like only 20 miles across. And that means there could be a difference tremendously in the amount of damage that area receives, depending on just that little small difference in where that hurricane went. One of the conditions that's necessary for a hurricane is it must have sea surface water temperatures greater than 80 degrees to at least 150 feet down in the water. So you also need Coriolis effect. So it can't be too close to the equator, or you're going to wind up with the Coriolis effect not there. And aloft, the winds must be weak. In other words, basically almost like a high pressure over top the system. And humid air through the whole column of the atmosphere. So in other words, if it gets dry air into it, it doesn't like that very well. Here you can see how water temperatures go sometimes along the eastern United States and the Gulf of Mexico. There is a very, very warm eddy in the western part of the Gulf of Mexico and up through the Caribbean and stuff before it falls into the Gulf Stream. There's another loop current there that's very warm, tends to have very high sea surface temperatures. And you can see them along the east coast. There's sometimes little patches that bubble out closer to the coast, particularly in the summertime. And these can influence these tropical systems. So we know that they can't, during El Nino, winds pick up in the tropics, but La Nina tends to have lighter winds in the tropics. That's why La Nina tends to be a time of favorable tropical storms and hurricanes. There are 84.9, 0.9 named tropical cyclones average, so almost 85. And half of those strengthen into hurricanes. The Western Pacific actually averages more than anywhere else. Eastern Pacific is a little less, and then over us, we actually have less than that. But you can see the number of storms can dramatically change from year to year. And here you can see basically where the hurricanes go. Notice the Eastern Pacific ones. Think about it. You have an easterly flow down here, so hurricanes are going to tend to move towards the west. That's why hurricanes in the Atlantic or the Gulf of Mexico tend to hit the United States or somewhere. But by the same token, Hurricanes and typhoons that develop in the Pacific do not. Here you can see the timing of the year. Notice that most of them start really ramping up in August and reach a peak in early September, and then gradually go back down till where there's almost nothing by November. Here are the breeding grounds. You'll notice they kind of impacted by the water temperatures. Water warms first in the Gulf of Mexico, then it begins to warm a little bit more along the eastern United States to flow on the Gulf Stream. But then by August, you're starting to get warm water all the way across the Atlantic, and you get a lot more storms developing coming off of Africa. Tropical disturbances are part of this. They move off of Africa on a regular basis. Many of these are fairly weak, and sometimes they move right along the intertropical convergence zone. And most of the precipitation, guess what, is actually on the east side of these storms. So in other words, a tropical wave may pass your house, and then you would get more rainfall if you lived in Florida, for example. So Saharan air layer, that is a layer of very dry, dusty, stable air. It originates over the Sahara Desert. It originates from thunderstorms and all that tend to develop but don't produce any rainfall there. When they develop, they push out a lot of dry, dusty air up into the atmosphere, and this flows with the easterly flow across the Gulf, across the Atlantic. And with that easterly flow, sometimes it'll even go places like San Juan, for example, may get visibilities down to a half mile in dust and haze when these go by. And even parts of the eastern parts of the United States, particularly Florida, gets these. And when they do go by, think about it. They're very dry, they're dusty, very stable. They will kill a hurricane if hurricane comes in contact with this, or prevent them from forming. So hurricanes get a lot of their energy from water vapor condensing within the storm, which releases a latent heat, and that heated air rises. So you need a lot of moisture continually going into the storm to produce it. Tropical depressions, maximum sustained winds, about 23 miles per hour or a little higher before you can call them a tropical depression. Oh yeah, they must have a closed circulation. If you looked many times at the weather maps in the summertime and you see what they talk about as, well, this may become a tropical depression, one of the first things they look for is winds flowing counterclockwise around the whole system. If they're not, then they can't close off a low pressure system there. It's more of a wave, and that means it's not a tropical depression. And then you can also have tropical storms and eventually hurricanes. And here you can see the damage from these. Look at the storm surge. It causes the most deaths. And rain is right next behind it. So flooding is the main issue, not the winds, and not necessarily the surfing. And here you can see how far inland the flooding can go sometimes. Here was Port Arthur, Texas, and how this came up. Here was another one. Harvey was one of the most tremendous, prolific rainfall makers over the Houston area. And some totals in that area were over 50 inches over 4-day total. That's a ridiculous amount of rainfall. So the wind develops to a pressure gradient. Pressure's got to drop. And it does damages by little whirlpools that sometimes develop in the middle of the hurricane. And they really diminish rapidly. Friction immediately at the coast will begin to diminish the winds. Remember, there's less friction over water, so you don't have as much there. And as friction hits, you also get dry land instead of all the moisture that's coming in from the ocean to it, both of which are weakening it. Storm surge, what is that? Okay, if you have wind, and you're going to learn all about this with Sandy, because Sandy had a tremendous storm surge. You have sweeps up to the coastline, the wind keeps blowing onshore in one area. Oh yeah, remember, it's blowing counterclockwise. So there'll also be one area that's blowing offshore. So that area is actually going to get very low tides, where the area that's flowing onshore is pushing the water onto the coast there and causing tremendously high tides. And here you can actually see it. It actually ranges sea level, maybe as much as 18 feet sometimes. And if it does that, when the waves are hitting, let's face it, if you had a house that was there by the ocean, it's not going to survive that. And that's why you can see here when Michael came ashore, all the damage that these storm surge did. Camille was one of the worst storm surges in history with 24 feet and also caused 256 deaths from that storm surge. Katrina, you really can't tell how much of a storm surge it had. They estimate over 20 feet in some parts of New Orleans area. Sandy, 12.5 foot almost. Storm surge at Kings Point. That's a record. And storm surge is produced by these, and it's forecasted by SLOSH, which is an acronym for Sea Lake and Overland Surges from Hurricanes. And you can notice a trend in hurricanes. They've actually increased more and more with time here lately. Maybe due to higher sea surface temperatures, maybe just an anomaly over time. But here you can see an Atlantic multi-decadal oscillation, which is a temperature change. We're in a warm phase right now, and we have been for a while, and they go for a while. But you'll notice in the 60s, 70s, and 80s, and actually when I was in college, we kept wanting to go find a hurricane. We couldn't. There were none around. Probably a good thing looking back, but the water temperatures were just a little bit cooler than normal then. So there's some conclusions. If the cyclone changes by 2 degrees or so, what you'll see, which may happen with global warming, basically you get more intense hurricanes. You don't necessarily get more hurricanes. And oh yeah, if the air temperature is warmer, holds more moisture, you wind up with a better chance for water that way getting into the atmosphere, causing more rainfall as well. And notice back in the 70s and 80s, there weren't many hurricanes hit land. And with that, people tended to move to the coast. And now that we've started that population, they're staying there. Barrier islands, they tend to form, the outer banks are actually a barrier island. That's why a lot of times when they get hit with a hurricane, they cause tremendous damage to there. Not as much damage where the main part of the Carolinas is, the coast there. We actually have a barrier island here in Virginia Beach. So there's all the evacuations and all. So I just wanted to show one quick current hurricane that's going on, which is out in the Pacific. We got none in the Atlantic. But here is a hurricane in the Pacific called Frank. And if you were to look, right there is the eye, and you can see some very intense, very high clouds around it. Not all the way closed around it, but it's still intensifying. And oh yeah, we talk about bands. You can see the eye wall. Here is one band. Here is another band. So you can actually see maybe even another one here. 3 distinct bands around that hurricane. So hope you get a little bit out of this. Let me know if you have any questions.